when we talk about the number system, we start with the counting numbers or the natural numbers. And these are called the natural numbers because these are numbers that we first used. So when we started thinking about how many things and actually wanting to know exactly how many, we started counting with 1, 2, 3, and we had this natural system of counting. And in fact, there are probably a lot of animals that also use this natural number system. Okay, because they would just naturally count one object, 2 objects, 3 objects. So at some point down the road, we actually came up with fractions, but a lot farther down the road, we came up with whole numbers. Okay, so whole numbers are actually quite new. The 0 is not very intuitive because why do we need a number that represents nothing? Okay, that didn't really make sense. So that 0 that we add to make to go from counting numbers to whole numbers, that 0 was added in a long time after we figured out counting numbers. And the reason why we kind of thought maybe we needed a 0 is because we wanted to talk about integers or negative numbers. So we have +1, -1, but there's something that we need to pass before we say we have -1. Okay, so for example, if I have $1 versus I owe $1, at some point, if I want to go from having $1 to owing $1, at some point I'd have to get to having no money. And so that's where the 0 came from. It really came from the fact that we wanted to use integers. So the integers are then going to be all the whole numbers with the negative versions of those numbers. And then we have the rational numbers, which are fractions. Okay, they can be written as fractions or they can be written as decimals that have a repeating decimal. And then lastly, what we're going to get into is the irrational numbers. The irrational numbers are numbers that cannot be put into a fraction. So rational numbers are numbers that can be put into fractions. Irrational numbers are numbers that cannot be put into fractions. And one that we've encountered already is a number called pi. And pi is the ratio of the circumference to the diameter. Now that ratio cannot ever be written as a whole number ratio. They tried. They said, oh, maybe 22 over pi is approximately 22 over 7, but that really wasn't quite good enough. And they figured out a long time later, so irrational numbers, people didn't really think that irrational numbers existed for a long time, a number that cannot be put into a fraction, but they do. These numbers are numbers that cannot be put into a fraction. They prove that this number pi cannot be put into a fraction. And so the decimal expansion ends up being 3.14159, etc. And it never repeats, it never terminates. So there's many numbers like this. Another famous number is E, or Euler's constant. And the E is approximately 2.712, and it just keeps on going on. And that number is very just happens to show up in math all the time, just like pi. Pi just doesn't show up in circles. It shows up all over the place in probability, in all sorts of different places. So pi and E are special numbers. They're called transcendental numbers, okay, and they are irrational. And there's a whole other set of irrational numbers that we call algebraic irrationals that we can find with roots. So if we square root 2, we cannot put that number into a ratio of 2 whole numbers. It ends up being this decimal that is really awkward, or non-repeating, non-terminating decimal. So if we take a look at the number system in a Venn diagram, we have the natural numbers. If we include the whole number, if we include 0, we have the whole number set. If we include all the negative numbers, we have now the integers. If we include the fractions, we have all the rational numbers. And the rational numbers and the irrational numbers make up the real number system. And outside of this, there's actually something called the imaginary numbers. okay, out here. So these are imaginary numbers. We won't really get into those, but well, there they are up here, but those are imaginary numbers. Now, this Venn diagram is a little bit misleading because there is irrational, rational numbers. Those two numbers alone make up the real number system. There's no gray area here. So what I'd like you to do is I would like you to work on that CK12 assessment, the geometry tools. This is looking at rationals and irrational numbers, okay, the number system. And also watch the video on irrational numbers, and then you can come back to these notes.